Okay, so I'm going to distribute first, outer, inner, last. So I get a squared minus abi. When you have multiple letters, I put it in alphabetical order. Makes it easier to see the like terms. Okay, so these two are like terms and they cancel out to 0. Okay, a squared and minus b squared, I squared. Well, I squared is -1. Okay, so this simplifies to a squared plus b squared. Notice how that minus changes signs when I replace the I squared. That's it. Guys, these are called conjugates because the result was rational. When you multiply conjugates, I don't really expect to see you do this. I expect to see you do this. Right? You should know that the inner and the outer cancel, and that I squared turns to -1, which makes minus minus a plus b squared. Okay, so now I'm going to do question 2. Multiplicative identity is equal to 1. Whatever you want to multiply by, it better be the multiplicative identity because there's no equals. Means it's got to stay equivalent. Now I said smallest quantity possible. Well, really, this I is root -1. That's the only thing that's a radical. That's the only thing I want to cancel out or turn into a rational number. So I'm going to try I. Not 3i. I'm going to try I. 3 is not a radical. I is the radical. That's the part I'm trying to rationalize. So I'm going to multiply the, well, I'll do the denominator first because that's really the part I'm interested in. Minus 3i squared. What does that turn into? 3. The sign changes. When you have I squared, the sign changes because I squared is -1. -3 times -1 is +3. Did your denominator turn into a rational number? Yes. Did it turn into the smallest rational number possible? Probably. Okay, so now I'm going to go back and distribute my numerator. 2i minus 3i squared, which actually turns into +3 plus 2i. Now I'm not quite done because that's not exactly in standard form yet. It's not split apart. So let's write the final answer. I'm going to divide my 3 in both places. 3/3 plus 2i/3, which is actually 1 plus 2/3 I. Be careful with your division. I picked numbers that were the same on purpose. Yes?
But if you multiply by 3i, would that
you will eventually get to the same reduced answer as I do. It'll just take you 1 or 2 steps more. Okay? So notice here, minus 3i, I picked something distracting on purpose. They do not equal 1. Right? You have to divide both the 2 and the 3i. You can't just cancel it out in one place and say 2 minus 1 or 2 plus 1. You can't do that. Make sure that you're following the, I don't know, properties correctly. Okay? What if, right, there's always multiple ways to your PEMDAS. As long as you do the rules correctly, it'll work. What if I do this? Minus 2/3i plus 1. Can I do this? Yes, because I divided the 3i in both places. Could I do my multiplicative identity here by multiplying by I on the top and the bottom? Yes. I could do that, but look how I ended up in the same place. There's multiple ways to get there. You just have to make sure that you're doing your properties correctly. Okay, so now I'm going to do the next one, which is the longest problem. Okay, rationalize the denominator. Now I see that the 4 and the 2 could possibly reduce, but the 4 and the 3 don't. And so this is not as easy to split apart as this one was, right? The single denominator is easier to rewrite. This time, I'm going to use a fancy form of the multiplicative identity in the conjugate form, right? Conjugate. Why? Because I know if I multiply conjugates from the first example, I get a rational number. Okay. Multiply. So I'm going to distribute 8i plus 12i squared. First, outer, inner, last. Yeah, I don't expect to see the outer and the inner when they cancel out. You guys are Algebra 2 honors. Do not show me the outer and the inner if they cancel out. Do it on scratch paper. Don't put it in the middle of your work. Okay, replace, right? My answer format is always this. Means you have to take all higher powers of I and rotate them down. Okay, so we're going to get 8i minus 12. 4 plus 9. Notice that replacing I squared just changes the sign on that number. Okay, I'm going to put it in the correct format. Put my real parts first and my imaginary part second. Technically, I should split this up. Just in case I was going to graph it. There's no good reason to graph that one. Besides, it's in quadrant 2. If I wanted to. Okay, into your homework questions. I'm not going to do everything from your homework, but I will do a few of them. What would you like to see? Only from worksheet 1 right now. I will answer worksheet 2 questions when it becomes relevant. Okay. What would you like to see from worksheet 1? Yes. 7. Yeah, okay, good question. Number 7. That's the most interesting of the top half. All right. Yeah. The only thing tricky here is that you've got 3 things to multiply. When you have 3 things to multiply, just pick 2 at a time. Okay? So I'm just going to pick the first 2, and I get positive 8i squared, which is really negative 8, and then I'll distribute to the next one. Does that answer your question? Okay, so guys, no calculator. 32 minus 40i. This is no calculator. You can do this arithmetic. What else would you like to see?
Just making sure it doesn't matter what order it's in. So you could either do negative 40i plus 32 or 32 minus 40i.
I'm not going to take off if the correct numbers are in the wrong order, but you should put the real part first and the imaginary part second.
Okay.
Like if you ever see multiple choice, they're always going to write it that way.
So
But no, I'm not going to take.
Where the plus is, it just matters where the number is.
Yeah, it matters where the I is. The I part should come second. And really, this just means that B is negative 40. It doesn't have to be a positive number. Technically, could be positive or negative. Well, so could A. It's the placement, first and second place. Okay, other questions from the front? 30. Yeah. Okay, so keeping in mind, I'm going to draw my I clock. Okay, I squared is negative 1. I cubed is negative I. And I to the 4th is 1. I can rotate through any positive or negative quantity here. All right, I can get negative 1 or positive 1. I can get positive I or negative I. And so I'm looking at my coefficients, and I'm seeing how can I get to positive 2. Well, it kind of stands out to me. I can do 1 and 3, or I can do 3 and 5. How do I get to 3? 1 and 4. Okay, so I'm sort of going to look at combining these two things to get the 3, and I'm going to look at combining these two things to get the 2. All right, I have 3 and 5, means I want this one to be negative 3 and this one to be positive 5, which means I'm looking to get the i's to disappear, right? Become a rational number. That's here and here. Those are the two things that get rid of the i's. Those are the two powers, squared or 4. Okay, so I need, right, so I'm aiming to combine these two things to get the 2. That means I need a positive 5, so I need this to be a 4th power because that's going to give me plus 5. And I need this one to be negative 1, that's a square, to get me negative 3. Okay, those two reds combine to positive 2. I'm looking more at the coefficients than the i's. So then I pick the right power to make it work. Okay, so I need, this one is a little tricky because I need this to be positive 4 and this to be negative 1. Well, really I need this to be positive 4i. So I need it to be up here or here. I think I have to do a 3 because that's going to give me positive 4i. This, I need it to be negative I, so this also has to be cubed, right? Yes? Yeah, cubed. They're both cubed. Yeah, okay. Does that answer your question? Look more for the coefficients and then pick the corresponding power that will rotate to the correct positive or negative quantity that you need. Okay, anything from the, yes? Yep, second page, sure. Okay, so this is kind of like a review question because I'm going to plot it 1, 2, 3, 1, 2, 3. That's right here. Now this is the real and this is the imaginary. So I plotted my point, which is really here. That's the point. That's the coordinate on the grid. I want the distance from here to the origin. Guys, that's the distance formula from geometry, or distance formula is not my favorite. I prefer just to draw a right triangle and do the Pythagorean theorem. A squared, B squared, C squared. It's actually, the Pythagorean theorem is the distance formula. They're the exact same thing. Just one has a lot more coordinates in it than the other. And so we end up with A squared plus B squared equals C squared. Just in case you did the distance formula, when you subtract and square those things, you get this. So you get the square root of 18. So the distance equals 3 root 2. Positive, obviously, because distance is a positive quantity.
You're solving for C?
Yes. I just relabel here. You want to C squared or distance equals the square root of subtracting the coordinates. Yes.
19.
Okay, so when I look at 19, I see all those coefficients are actually even. So I feel like I could reduce them, but I'll wait till the end. Maybe you don't notice the reducing. The tricky part about 19 is that you've got a leading negative, okay? So my multiplicative identity is only going to change the sign on the imaginary part, okay? Whatever you do, you have to make sure that the outer and inner are actually going to cancel. Okay, so I get minus 8i plus 4i squared on the top. And on the bottom, I get negative times negative is positive 16. Okay, there's my outer is negative, my inner is positive, and then I get minus 4i squared. Do not cross things out, guys. You cannot cross out the 4i squared and the minus 4i squared. It's not how fractions reduce. I am, however, going to reduce my powers. Negative 4 minus 8i, positive 4, so over 20. Now I'm going to split and reduce. So what is that? Minus 1/5 and minus 2/5. You could have reduced the 2 first. I just happened to do it last here. But you should always give me completely simplified answers. Like 4/6 is not the correct answer. It's 2/3, right? You should always reduce. Okay. Anything else from the homework? Okay, on your quizzes, guys, let's talk.